Bashar. You are watching the channel Techquest Learning Point, and I am here with a new episode of the tutorial Programming C# for Beginners. Today I am going to start 5th episode on the new topic decision making and looping in C#, and it's the 5th episode of this series of tutorial Programming C# for Beginners. It's a complete C# programming course which enable any learner to make their basic foundation on C# programming, where 4 number of episode has already been discussed with lab in Visual Studio 2022 environment. In this episode, I will discuss on for loop, while loop, do while loop, and for each loop, as well as I will show with example how these statements work in C# program in Visual Studio 2022. Okay, let's start. Understanding looping is a fundamental concept in programming that allows you to execute a block of code repeatedly until a certain condition is met. We use a loop when we need to execute a specific block of code multiple times based on a condition. Otherwise, we would have to repeat the same line multiple times. Let's say we want to print all even numbers from 1 to 10. For this purpose, we need to write the code for checking and printing each number from 1 to 10. That means 10 lines code is required, but if we go through a loop, few lines is enough. C# provides several looping constructs to achieve this. Number 1, for loop. Number 2, while loop. Number 3, do while loop. Number 4, for each loop. Break statement. Use break to exit a loop permanently. Continue statement is used to skip the current iteration and move to the next one. Choose the appropriate loop based on the problems you are solving and desired control flow. Before starting the discussion about looping in details, take an idea on what are the advantages of looping. Repetition. Loops allow you to execute the same code block multiple times without rewriting it, saving time and effort. Handling collections. They enable you to efficiently process elements within arrays, lists, and other collections. Problem solving. They are essential for solving many programming problems that involve repetition, such as calculating sums or averages, searching for items in collections, generating sequences of numbers, validating user input, creating animations or simulations. Readability. While structured loops can improve code readability and maintainability. Disadvantages. Infinite loops. If the loop condition is never met, it can result in an infinite loop, causing the problem to hang or crash. Careful logic is crucial. Performance impact. Large or complex loops can impact performance, especially when processing large data sets. Consider optimizations if necessary. Complexity. Nested loops or intricate loop logic can make code harder to understand and debug. Use clear variable names and comments for clarity. Debugging challenges. Troubleshooting errors within loops can be more challenging as you need to trace the execution flow through multiple iterations. For loop. Syntax. For initialization, condition, increment or decrement. Initialization. Executed only once before the loop begins. Typically used to declare and initialize a loop counter variable. Condition. Checked before each iteration of the loop. If the condition is true, the code block inside the loop executes. If the condition is false, the loop terminates. Increment decrement executed after each iteration of the loop, usually used to loop update the loop counter variable, typically to move towards the termination condition. Example: initialization. Int I equal to 1 declares and initializes the loop counter variable I with the value 1. Condition: I is less than equal to 10 checks if I is less than or equal to 10. If true, the code block executes. Code block: console.writeLine number 0, I prints the current value of I. Increment: I++ increments I by 1 after each iteration. Loop repeats. Steps 2 4 repeat until the condition I is less than equal to 10 becomes false when I reaches 11. The loop counter variable is often an integer, but it can be any data type. The initialization and increment decrement parts can contain multiple expressions separated by commas. The condition can be any Boolean expression. The break statement can be used to exit a loop prematurely, while continue can skip the current iteration and move to the next one. While loop. While loop syntax. Condition check. The loop begins by evaluating the specified condition. If true, if the condition is true, the code block within the loop executes. Code execution. The code block contains the statements that you want to repeat as long as the condition remains true. Looping back. After the code block finishes executing, the loop returns to step 1 and re-evaluates the condition. If false. If the condition becomes false, the loop terminates and program execution continues with the code following loop. The condition is checked before each iteration of the loop. If the condition is initially false, the code block will not execute even once. It's essential to ensure that the loop condition will eventually become false to avoid an infinite loop. Example: int I equal to 1 initialize counter variable. While I is less than equal to 5, console.writeLine number 0, I print the current number. Increment the counter. Output number 1, number 2, number 3, number 4, number 5. The variable I is initialized to 1. The condition I is less than equal to 5 is checked. Since it's true, 1 is less than or equal to 5. The code block executes. The code block prints number 1. The counter I is incremented by 2. The loop returns to step 2 and checks the condition again. This process repeats until I becomes 6, making the condition false and ending the loop. Do while loop. Syntax. The code block within the do section always executes at least once, even if the condition is initially false. The condition is checked after each iteration of the loop rather than before. If the condition is true, the loop continues and executes the code block again. If the condition becomes false, the loop terminates. Example: int I equal to 0. Do console.writeLine number 0. Print the current number. Output number 0, number 1, number 2, number 3, number 4. The variable I is initialized to 0. The code block within the do section executes printing number 0. The condition I is less than 5 is checked. Since it's true, 0 is less than 5. The loop continues. The counter I is incremented to 1. The code block executes again, printing number 1. Steps 4 5 repeat until I becomes 5, making the conditions false. The loop terminates. When you need to ensure that the code block executes at least once, even if the condition might be false initially. While you are dealing with user input or other external factors that might initially fail to meet the condition, while the loop's logic requires at least one iteration to establish a valid condition check. Nested loop. Nested loops occur when one loop is placed within the body of another loop, creating a hierarchy of iterations. This allows for more complex control flow and the ability to process data in multiple dimensions. Example: output. Outer loop. It iterates 3 times I equal to 1, 2, 3. For each outer iteration, the entire inner loop executes. Inner loop. It iterates 4 times j equal to 1, 2, 3, 4. It prints a star for each combination of I and j. New line. After each outer iteration, a new line is printed, creating the rectangular pattern. The inner loop runs to completion for each iteration of the outer loop. The nested loops can be used with any combination of for, while, and do while loops. They are often used for multi-dimensional arrays, as for example processing rows and columns, nested data structures, as for example traversing trees or graphs, generating patterns or sequences, solving problems that involve nested iterations. Be cautious of potential performance implications with deeply nested loops. Use meaningful variable names to enhance code readability. Consider using indentation to clearly visualize the nesting structure. Break down complex nested loops into smaller, more manageable functions to better organization. Break and continue statement. Break statement terminates the loop immediately, regardless of whether the loop condition is still true. Control flow jumps to statement following the loop. Example: output 1, 2, 3, 4. Continue statement skips the remaining code in the current iteration and moves to the next iteration of the loop. It does not terminate the loop entirely. Example: output 1, 2, 3, 4, 1, 3, 5, 7, 9. Break can be used with for, while, do while, and switch statements. Continue can be used with for, while, and do while loops. Use break to exit a loop prematurely when a specific condition is met. Use continue to skip a specific iteration and move to the next one, often for filtering or conditional execution. Use them judiciously to avoid unintended consequences and maintain code clarity. Now I am going to demonstrate some code snippet to clear the loop in C# with Visual Studio 2022. Let's write code. It's a very simple and small code snippet that make you clear on the for loop in C#. Let's run the program to check the program is work correctly or not. The sum of the 5 natural number is 15. That means it's working correctly. Have a look in the code snippet. First, declares and initializes the integer variable sum to 0, which will store the accumulated sum. Alternatively, an integer sum variable will be used to store the summation of all numbers within range 5, and summation occurs with each iteration. Here, loop iterates 5 times from 1 to 5. Loop iterates 5 times from 1 to 5. This is the for loop. Int I equal to 1 initializes a loop counter variable I to 1. That means loop will start with the value 1 for I. If I is less than equal to 5. This is the loop condition. The loop will continue as long as I is less than or equal to 5. Loop will stop when I is 6. In the last iteration, I is 5. I plus plus. This is the increment expression which increases the value of I by 1 after each loop iteration. Add the current number 1 to the sum. Sum plus equal to I. Inside the loop body, the current value of I is added to the sum variable during the first iteration. Variable sum is 0 and I is 1. After executing this line, sum will be 1 and I will be remain same value, that is 1. More specifically, first I is added to sum and then assigned to sum. In simply, value of I 1 is added to value of sum 0. It will be 1 plus 0 equal to 1 and 1 is assigned to sum. In the second iteration, I is 2 and sum is 1. We know that first addition and then assign. That means value of I 2 is added to the value of sum 1 and then result 3 is assigned to the sum. Console.write line. After the loop completes, this line prints the final value of sum to the console. I hope this small code snippet make your concept clear about for loop in C#. Now you need to practice for understanding better. Now I want to demonstrate the code snippet with while loop. This small and simple code snippet explains the execution of the while loop. Here is the problem find all even numbers within the range from 1 to 10 using the while loop. Okay, this code snippet will find the even numbers, all even numbers within the range from 1 to 10. Okay, execute the program. These are the even number 2, 4, 6, 8, and 10. Initialize counter variable I is used to count the number of iteration and make the condition statement. I is less than equal to 10 is the condition statement. If the statement return true, the loop will execute, otherwise it will stop. This statement will return false when I is 11. Here is the two operators in this expression. One is modulus operator, another is equal operator. By the first operator, it returns remainder of division, where the value of I is divided by 2. Here is the very simple logic that any even number is always divisible by 2, and it returns 0 remainder. As a result, the if statement is always true for any even value of I. Console.writeLine, for any even number, this line print the value. This is the increment expression which increases the value of I by 1 after each loop iteration. Finally, I will demonstrate the code snippet with do-while loop. Do-while loop is the same as while loop, except the code block within the do section always execute at least once, even if the condition is initially false. Here I is initialized integer variable. Console.writeLine print the number value of I. I increases 1 by 1. This is the condition of this loop. Condition is checked. If the I is less than 5, then condition iterate again. Okay, let's run. Number 0 to 4, that means the loop is iterates 5 times. Let's put the value 4. Okay. Run the program. I is 4. 4 is print. Now I is increment. Increase 1 and 5 it will be. Now I is 5. 5 is not less than 5. That means this condition is false. Loop will be stopped. Value 4. Okay. That means the condition is false, but loop iterates at least one time.